Come revise GCSE chemistry with me. Why did scientists accept Dmitry Mendeleev's version of the periodic table? Scientists have been trying for a really long time before Mendeleev to put the elements that they knew about into groups that would allow them to make predictions. There's no point wasting a load of time or money on an experiment that's just not going to work, so it's really helpful to know which kinds of elements are kind of similar to each other. A guy called John Newlands came up with the idea of octaves. Now, if you know music, you'll know that an octave is a scale from 1 to 8. And for this bit to make sense, you need to know that the noble gases hadn't been discovered yet, because it's kind of hard to discover something that doesn't react with or interact with anything else. So Newlands had the elements in some kind of order, and he realised that in the same way that a scale goes 1, 2, 3, 4, 5, 6, 7, 8, these elements could go lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, skipping neon because it's a noble gas and it hadn't been discovered yet, sodium, which is also an alkali metal like lithium is. So that was a really handy pattern, but unfortunately then the pattern broke down. We now understand that this is because of atomic structure. So you've learnt that we can fit 8 electrons in the second shell, but that pattern doesn't continue forever. So anyway, at this point, scientists were arranging elements in order of their atomic weight. Nowadays, we use proton number or atomic number, so why were they not doing that? Well, protons weren't discovered until the early 20th century, and these guys were alive at the end of the 19th century, so they couldn't put elements in orders of something that hadn't been discovered yet. Anyway, enter Russian chemist Dmitry Mendeleev. He still placed the known elements in order of atomic weight, but he made 2 crucial changes. Firstly, he spotted that some elements didn't fit the pattern. We now know that this is because although atomic weight and atomic number track pretty well together, sometimes they don't. Now, I just said that the noble gases hadn't been discovered yet, but I'm going to explain this using a noble gas, just because if I used the elements he really used, you probably wouldn't have heard of them. So if you think about potassium and argon, argon has a mass of 40 and potassium has a mass of 39. So in Dmitry Mendeleev's periodic table, they should have been the wrong way round. But that would put potassium, a really soft, really reactive metal, with the noble gases, and then argon, which is an unreactive gas, with the alkali metals. It just doesn't make sense. So Mendeleev said, I don't know why it's wrong, but it clearly is wrong, and he swapped those elements around. Disclaimer, this wasn't actually potassium and argon, but it's the same kind of thing. Now, the other thing that he did was he realised there were some places where he needed an element and there wasn't anything that had those properties. So he left some gaps, but he also predicted what would go in the gaps. So he said, oh, we're going to find an element and it'll have this mass, this density, this kind of reactivity. And this is why the other scientists accepted his periodic table. Because in a few years' time, we discovered those elements. And it turned out that all of his predictions were bang on. So important things about Mendeleev. He swapped around elements that didn't fit the pattern, he left gaps, he made predictions about those gaps, and then it turned out that those predictions were right.